Physics Lab 3 was called Magnetic Field of Permanent Dipole Magnets. The goal of this lab was to observe the effect of distance on the magnetic field experienced by a small bar magnet. The lab tasked us with using a magnetometer app and a bar magnet to measure and compare the magnetic fields at different distances from the bar magnet. At the end of the lab resulted in getting a B value 45 degrees from the axis at distance d of negative 6.519 e negative 7 Tesla in the x direction, 1.955 e negative 6 Tesla in the y direction, and 0 Tesla in the z direction. I also ended up with an n value of negative 2.1518 based on my data. There were many different physics principles explored in the third lab. This lab taught us a lot about the magnetic moments and magnetic fields and how they differ when they are on versus off of an axis. Additionally, the main physics principle explored was Biot-Savart law. Biot-Savart law gives us an equation to relate mu and r to calculate for the magnetic field through the equation B equals mu naught over 4 pi r cubed times the value 3 times mu dot r times r hat minus mu. Other additional equations this lab utilized were the magnitude of B bar equals k r to the n and ln magnitude of Bx equals ln k plus n ln r. This lab was set up by first aligning your phone towards the Earth's north-south magnetic field so that the magnetic field of the Earth would not influence the data. The starting magnetic field, when no magnet has been introduced, is highly dependent on what location the experiment was performed. Using a magnetometer app of your choice, mine was called Teslometer, the next step was to record the magnetic field vector based on given distances. The next part of the lab included turning the phone a 45-degree angle and repeating the measurement stage to see how the results of the experiment vary. On this slide, I have included all of my data. As you can see, my ln Bx versus ln r graph appears to create a linear negative line. The slope of the line was negative 2.1518, and this is also my resultant n value that are used in my later calculations. My y-intercept was equal to negative 14.605. There were two possible ways to calculate the average magnetic dipole mu. The first is to find the value of mu at each distance and average them together. The second way would be to use the slope and the y-intercept of the line created on the last slide to solve for an average mu. The way that I solved for my average mu was by taking and solving for the mu at each distance and then taking the average using the equations k equals e to the ln k and the magnitude of B bar equals k r to the n. I also used the idea that the magnitude of the B bar equals the magnitude of B dipole. And rearranging the equations, I solved for mu. In this example, for R20, I calculated a mu value of 5e negative 1. When I averaged the mu values together, I got an average mu value of 0.297. I also solved for d perp average by summing the values and dividing by the trials at each r value. Once the average mu value has been calculated, it was placed inside the code. The function to calculate the magnetic field and the calculated d perp had been included into the code as well. The scales were adjusted and arrows were created in order to see the magnetic field on the axis and 45 degrees from the axis. The scales were adjusted to make the glow script to have the arrows be easier to see. If we hadn't lined up the magnet to compensate for the magnetic north, the experimental values would not line up as well with the calculations because the calculations do not take into account any additional external magnetic fields. Also, if the magnet was connected to another identical magnet, we would have observed a stronger magnetic field than we did in the experiment. In conclusion, there was an n value of negative 2.15 and a magnetic field vector at 45 degrees at distance d of 6.51 e negative 7, 1.955 e negative 6, 0. Two things that were observed were that far from the magnet, the magnometer measured a non-zero magnetic field in the x direction, and that when the magnometer was moved to the magnet, the magnetic field would increase in the x direction.